What if I told you the universe isn't expanding the way we think it is? What if the edge of the cosmos isn't a boundary at all, but a vast shifting mystery, one that challenges everything we thought we knew about space and time? Imagine a place where the very laws of physics begin to unravel, where light can't even escape. And yet beyond this realm, there could be an entire universe we can never reach, no matter how advanced our technology becomes. Today we embark on a journey to the edge of the known universe, where reality itself starts to blur. What lies beyond this cosmic horizon, and how does it redefine our understanding of everything, time, space, and even life itself? To start, let's talk about the universe as we know it. The observable universe is a vast expanse, about 93 billion light-years across. But here's the catch: this is only the portion of the universe that we can see. It's like standing on the shore looking out at a vast ocean and thinking that's all there is, when in reality, the ocean might stretch far beyond what the eye can see. Why? Well, space itself is expanding, and light takes time to reach us. The farther away something is, the longer it takes for its light to travel. Some galaxies have been speeding away from us, faster than light itself can reach us, due to the expansion of space. But is that all? Is this observable universe the complete picture? What lies beyond the galaxies and stars we can see? And how far does this truly go? You've probably heard of the Big Bang. But what if the Big Bang was only the beginning of a much larger cosmic process? Enter the idea of eternal inflation. In this theory, the universe didn't just expand once, it keeps expanding eternally in pockets. Some areas of space continue to inflate, giving rise to new bubble universes, each with its own set of physical laws. These bubbles could be vast, with some nearly identical to our own, while others might be radically different. Think of it like a cosmic soap bubble. Imagine that our universe is just one of many, floating in an infinite sea of these bubbles. But here's the kicker: we can never reach these other bubbles. Why? Because they are expanding faster than light itself can travel. The possibility of a multiverse, an infinite collection of parallel universes, is no longer just science fiction. Now, let's get even stranger. What happens beyond the edge of the observable universe? Beyond the light that reaches us? Light is our window into the cosmos, but it has limits. The furthest we can see is defined by something called the cosmic horizon, a line in space and time that light can't cross. This is not a wall, but a time boundary. Imagine lighting a candle in a pitch-black room. At first, the light only illuminates a small area. As time passes, the light spreads further out. That's how the universe works. We can only see as far as light has had time to travel since the Big Bang. But here's where it gets even more fascinating. As the universe expands, galaxies are racing away from us, and some will eventually be unreachable forever. So while we're constantly gaining new information, the universe is also moving away from us, and some galaxies will fade out of sight beyond our cosmic horizon. Speaking of horizons, let's talk about the horizon of time. The further we look into the universe, the further back in time we're seeing. But what if time itself, as we know it, is limited? And what if the way we measure time isn't quite as fixed as we think? Some cosmologists suggest that time doesn't move forward in a linear way. In fact, our present moment might not be the same as someone else's present moment in a distant part of the universe. Our now could be different from other regions now. This means that not only are we looking at distant galaxies in the past, but there could also be cosmic events taking place elsewhere that we'll never fully understand because we have no way of observing them due to the way time itself operates in the cosmos. So far, we've covered the limits of light, time, and space. But there's something else lurking beyond our understanding. Dark flow is a mysterious phenomenon, where massive galaxy clusters appear to be moving in a strange direction toward a region of space that we can't explain. What's causing this movement? Some think it could be the gravitational influence of objects beyond our observable universe. Could there be hidden structures, maybe even whole universes tugging on our own? But it doesn't stop there. There's also the cold spot in the cosmic microwave background, a mysterious area of the sky that's colder than expected. Some scientists believe this could be the result of a collision between our universe and another one, an imprint left in the very fabric of space-time. But this remains a mystery, and it's one that continues to spark intense debates. But wait, what if we're missing entire dimensions? What if our universe is just a tiny slice of a much bigger reality? Some theories, like the holographic principle, suggest that everything we experience is just a projection from a deeper two-dimensional reality. Picture this. The universe we live in could be a hologram, a 3D projection of information stored on a distant cosmic surface. And if there are hidden dimensions beyond our perception, could the edge of the universe be a doorway to these realms? What if there are multiple universes, each with its own set of physical laws, just waiting to be discovered in higher dimensional spaces? Finally, let's dive into something even wilder: quantum tunneling. What if the universe itself could tunnel from one state to another, crossing barriers that we thought were impossible to breach? In the quantum world, particles can appear on the other side of barriers they shouldn't be able to cross, and some theorists suggest the universe itself could do the same. Could we one day discover new realms of existence through quantum tunneling? These worlds might operate on completely different rules, with entirely different physics and dimensions. The very fabric of reality could be more malleable than we ever imagined. As we reach the edge of what we can observe and understand, we're faced with a vast universe full of questions that we may never fully answer. The observable universe, stretching across billions of galaxies and containing trillions of stars and planets, is only a fraction of what might be out there. Beyond what we can detect with our current technology lies the unknown, vast regions of space, time, and possibly dimensions that are hidden from our view. Our instruments can only detect a tiny fraction of the cosmos, and there's so much more that we haven't yet discovered. What exists beyond this observable boundary? Could there be regions where space and time behave differently, or even alternate dimensions that are out of our reach? Some of the most fascinating and mind-bending theories suggest that our universe may not be the only one. The concept of a multiverse proposes that countless other universes, each with its own physical laws and constants, might exist alongside our own. These universes could have completely different rules, maybe even alternate forms of matter or time. Then there's the possibility of other dimensions, realms that could exist on entirely different planes, where our rules of physics don't apply. These ideas are challenging, pushing the boundaries of what we understand, but they also offer a glimpse into the limitless possibilities of the cosmos. We're also faced with phenomena like dark matter and dark energy, which make up about 95% of the universe's mass and energy, yet remain completely invisible and undetectable. These hidden forces could be shaping the very structure of galaxies and the universe itself, yet we still have no clear understanding of what they are or how they work. As we peer deeper into space and advance our technology, we uncover more mysteries. Every discovery seems to bring up more questions than answers, making the pursuit of knowledge even more tantalizing. Theories like string theory and quantum mechanics continue to suggest that the nature of reality may be far more complex than we've ever imagined. Strange phenomena like particle entanglement and the possibility of parallel universes challenge everything we know about the laws of physics. The more we learn, the more we realize how little we truly understand. As science continues to push the limits of the observable universe, we may one day be able to answer some of these questions. But even as we unlock the deepest secrets of the cosmos, new mysteries will continue to unfold. The truth is, we are only scratching the surface of an infinite and uncharted universe. Each discovery brings us closer to understanding the immense complexity of space and time, but we still have so much to explore. And that, in itself, is one of the greatest mysteries, the questions we haven't even thought to ask yet. The universe, in all its vastness and complexity, is inviting us to keep exploring, to keep questioning, and to keep dreaming. Perhaps that's the most intriguing mystery of all, what lies just beyond the edge of our imagination waiting to be discovered.